Alright, what have we got here? What I have here are models of glycine molecules, two of them, and we want to show how to get two of these hooked together. And so there will be a question in your next test. You say, tell me what's on the test? Yes, it's in your study guide there. Show two glycine molecules being hooked together. And say, you sure it's going to be on the test? Well, I have not failed to put it on that first big test for the last 12 years. Think I'm going to fail you folks? No. And so this will be worth 5 points on your first big module test. And so what do we need to show? As we do this, we need to show, first of all, the before, two glycine molecules not hooked together. This would be the before picture. And so, didn't really mean to pick up the blue one, but let's switch down to black and represent two glycine molecules not hooked together. There, that represents two glycine molecules not hooked together. And again, before we hook them together, let's consider that fundamental question. Why would these two glycine molecules even bother considering being joined in holy chemical matrimony? And the answer is they would not. No, this is a shotgun marriage. They have to be hooked together. Something has to grab them and hook them together. And so what's doing the grabbing and hooking? Well, what did I call them? Assembly line worker molecules. And so what we can imagine is a much bigger molecule that grabs these two guys, hooks them together, lets them go, grabs two more, hooks them together, lets them go, grabs, just like an assembly line worker would do. And so you say, well, when you talk about huge worker molecules, we're talking about huge molecules, right? Macromolecules. And how many categories of macromolecules are there? There's only what? There's only 4. So it's got to be one of those 4. Is that right? Yes, it does have to be one of those 4. So these huge worker molecules happen to be huge protein molecules. And they have a specific term for them, and they are specifically called enzymes. And so enzymes have a whole lot more going for them than just digestion. We talked about digestive enzymes. Enzymes are the worker molecules on all the cell's assembly lines. Lots and lots and lots of different kinds of enzymes that are working on various places on the various assembly lines. Well, I'm going to erase that for right now. We'll talk more about enzymes here shortly. But what do the enzyme molecules do with these two little molecules that are going to get joined together? Well, we saw one thing they do. They grab an OH off that carboxyl group and a H off that carboxyl group and release that as one water molecule is released, right? One water molecule is produced or released. Then what gets joined to what here with the new molecule? Well, this C is joined to that N. And so what I would expect you then to show me is the after picture. After the two molecules are joined together, I'm going to kind of start from the left and work across to the right. So we'll start with what we've got here. And there's my amino group. There's the central carbon with the hydrogen, the R group, which is also hydrogen. But then we got some changes here. We have this carbon right here, and it still has a double bond to an oxygen, but it lost its OH group, right? And so it is connected directly to that nitrogen right there. And that nitrogen lost one of its hydrogens, but still has the other. And so then everything else is the same as we have had it before. So this represents the after picture, and this is what you need to come up with to get your 5 points. There it is. Now, continuing on another discussion, other aspects of the discussion, this new bond has a name. It is called what? It is called a peptide bond. And so what is a peptide bond? It is the bond between any two amino acids. That's the term for the bond between amino acids, is a peptide bond. And so in the previous video, we introduced the term polypeptide. Polypeptide. What does polypeptide mean? It means many peptide bonds, and it is more or less synonymous for protein. Not exactly synonymous. We'll see why, but a polypeptide chain is basically the basic component of a protein. There's more to a protein than just its amino acids, but we can just, they're kind of used interchangeably, polypeptide and protein. And so there you have it. Two glycines joined together to form this unit. Okay, that's it for this one.